Hi everyone, thanks for joining this session. This is basically a experience report of my team at Specmatic and folks at Geo, the largest telco in India. We've collaborated with TM Forum and we've created a project called API Forge to essentially streamline the entire API lifecycle. And so this experience report is going to walk us through the various things that were done as part of this. So let's dive straight in. So some of you probably are familiar with TM Forum. For those who are not, TM Forums is essentially a standards body which essentially helps various telcos around the world to interop. And essentially, what they have done is they have, you know, basically launched over 120 open API specifications, and we're slowly also launching async API specifications for these. And these specifications are what are used by different telcos and vendors who build products for telcos to basically adhere to the standards, allowing interop easily between them. So let's quickly switch slides and look at actually how this looks. So this is I'm on the TM Forums API directory. So as you can see, there are like lots of different APIs that have been that are already available. Let's quickly look at a product catalog. So what you will see here is that there are several assets that are basically available. There is an open API specification, there is a Postman collection, sample implementation, a CTK, which basically stands for conformance toolkit or certification toolkit, and so forth, right? So all of these artifacts are available for the members, and you will also see that we have a async version of all of these again, where you see async API specification, CTK, and so forth. But for today's talk, we will mostly focus on how these assets are basically made live here for the members to consume. And once they have these assets, then what do they actually do with them, right? How does this streamline the overall developer experience on the member side, right? So quickly coming back here, so let's look at essentially what is in TMF inside TM Forum. We have an API factory which essentially takes as input a rule file, and I'll explain that in a minute. But essentially, we take a rule file which depends on common schema, example, directory, and so forth. And then using the tooling that we have built in collaboration with them, we are able to produce these assets that you just saw, right? These assets are being produced through the tooling, right? And it's all of this is completely automated, so it is repeatable and scalable model, right? So this could be a set of members that come together, propose a new API standard, and then basically build that out using the tooling. Similarly, there could be other members who could propose a new API and so forth, right? So there are, at any given point in time, there are several of these APIs that are being built in parallel, and the tooling supports this, right? So without too much, I would like to kind of jump in and actually do a live demo of how do we go about producing these artifacts, right? So let's switch to my IDE here real quick. And what you will see is this is the OS Open API and data model directory. In this, if I just collapse this, you will see here are all the APIs. Like I said, about 120 of these APIs exist over here. And obviously their common schemas are all in these folders below, where all the common schemas are for different entities are stored, right? So for today, we will look at TMF trouble ticket, TMF 621, which is trouble ticket specification. And what we have here is essentially a rule file that we use. And let me quickly just collapse some of these things so that it's easier for you to understand what I'm going to explain. So in this rule file, what you will see is we essentially have two entities, trouble ticket and trouble ticket specification. Yeah, so this is essentially a rule file. And if we look at this, then essentially it has what is the schema for this particular trouble ticket. And the schema is, like I was highlighting, it is down in the schemas common trouble ticket folder. So we will be able to look at the common schema. So as a member, I need to define, for any given entity, what is the schema for this particular thing, and then what are the supported operations, the HTTP methods that are allowed on this thing. So in this case, we have get, post, patch, and delete. And then of course get is required, and post is also required. And in post, what are the required parameters, what are the excluded parameters, and so forth. And similarly, right, so you'll notice that this is a lot more crisp and condensed version, which allows us to then implement a whole set of patterns before generating the OpenAPI specification. And for those of you who have looked at OpenAPI specification, there is a lot more details in that, but asking the members to fill out all those details can be quite daunting, even like your designers and stuff like that. So at PMO Forum, what we've done is we've created this rule file, which is a much crisper version, and that allows us to implement several patterns in a consistent manner. Okay, so this is essentially a rule file. This is the only input that is required for us to get started. So let's quickly jump here, and I'm going to just start menu.sh. I'm going to show you a quick version of the tooling. So here I'm just kick-starting menu.sh, and what you will see here, let's hide these and other stuff. So what is presented to you is a quick workflow, right? Which allows us to take the rules file and go all the way through the several assets that I just showed you, the 6 different assets that were there on the website. We'll show you how we will produce each of them. All right. So step number 1, we need to generate the Open API specification and async API specification from the rule file. So let's kickstart that. And there we go. That's pretty much it. So if we come back here, you will see there's a new folder called async API, async. And then in this, you would see that we have a async API specification file. Similarly, if I were to go to the OS, you would see that we have an Open API specification. So notice we had this trouble ticket, and it had get. So all of these things are basically built out by the tooling, and all of these ref out so that we don't duplicate things and stuff like that. There are some interesting patterns, for example, that I would like to call out that we've implemented, right? So if we look at post, the post request is basically trouble ticket FVO, which is a factory value object, right? So what does the FVO do, right? The FVO basically has entity, which is all the standard things that we would want across any entity. It's all of, and then it has a bench of mandatory properties, right? So name, description, severity, these are very specific to trouble ticket, right? Ticket type. And then a whole bunch of them that are defined over here. And then out of these are the only required types, right? Now, what would typically happen is when I do a get request on this particular thing, all of this information would also be required. But I don't need to keep repeating this over and over again, right? So this is where with the FVO pattern, for example, we are able to then, when we do a get, we are able to say FVO plus the ID, right, which is like a primary key, is what I want to come back in the in my trouble ticket. So that way we avoid duplicating between the basically the different functions that we have, the different methods that we have. We are not duplicating that information. So that's quickly step number 1 that's helped us generate the Open API specification. So that's great. Let's quickly now look at step number 2, right? So we've got now the Open API specification, async API specification. Also important to highlight that both of the specifications are being generated out of the same set of rule file, right? Which gives us again standardization across Open API and async API. So now that we have the Open API specification, what is the next step that we need to do? As most of you know, examples are a very important part of any specification. Most people look for meaningful examples to understand your API specification. So step number 2 for us is to actually generate these examples. All right. So I'm going to just hit here step number 2. And this is going to bring up the server for us. Let's just quickly look at that. Da, 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 da. Okay, there we go. So what this is essentially, it is looked at the Open API specification and it said, okay, in the API specification, I have at the top level these two entities. We already saw these two resources or entity, the trouble ticket specification and the trouble ticket itself. And then on trouble ticket, I have the get and post. And then on trouble ticket ID, I have delete, get, and patch operations. Similarly, on trouble ticket specification. So this is just a visual way for us to look at what is in the Open API specification. And then, as you can see, none of the examples exist. So this is giving us an ability to generate these examples. So let me do this. I'm just going to select here and I'm going to say generate all the examples. So what you will see is slowly each of these examples. And so 18 examples got generated. Okay, but are these examples valid, right? Are they valid in the sense of, are they valid as per the Open API specification and the schema that we have? So let's quickly test that. And sure enough, all the 18 examples which we have generated are valid. Let's look at one of such examples, right? So I'm going to look at the post, so trouble ticket post and 201 response code. This is essentially the request body, the request payload with the body. As you can see, these are real world specifications. So the examples can be quite complicated. Now imagine sitting and handwriting all of this, right? This could be quite error prone, and which is why the tooling basically allows you to generate these examples and stuff like that. What more, right? So I might, whatever is generated, I might not be happy with it. I might want to change some of them. I might want to tweak some of these examples. So sure enough, we can go here and make these changes. Now, what happens if someone ends up, while making a change, make the change that is not compliant with the Open API specification, right? That's one of the common challenges we see, is a lot of the Open API specifications and their examples are out of sync, right? It's a kind of API drift, right, where things have drifted away. So what if I basically change this to false, right? This was severity was of type string. I've just changed it to false. Now let me try and validate this example. And sure enough, as you can see, it's basically highlighting that this is expected to be of type string, but got Boolean instead. So that, this is kind of giving you inline feedback to avoid you from making these kinds of mistakes. So let's change it back to critical, save it and validate it. And sure enough, it's a valid example now. So like this, one could go in and, basically validate all the different examples that are generated. If they want, few more options, you can always generate more options for the examples and then update them, right? So this is all very handy for you. So this is essentially example generation and validation step. So now if we go back, let's kind of continue with where we were. So we've now been able to successfully generate the examples. Let's quickly validate all of them once before we move forward. So we're going to quickly run all the examples, and sure enough, no errors were found in the examples. So that's great. Now I have the examples, what can I do with it, right? I obviously want to update back back these examples in the rule file, because that's our source of truth. From here, everything else works, right? So I'm going to quickly update these examples back in the rules file. And there we go. All the examples have been successfully written back into the rule file. Let's quickly look at the rule file now and see what has happened. So you will notice in the rule file now, there are wherever there are schemas, there are examples associated with them, and we have all the examples with the respective schemas and example files over there. So this is great. Now we have our examples back in the rule file. So let's now move on and generate the OS file and the async API specification with these examples updated, right? Basically, let's inline these examples into the specifications itself. So I'm going to hit number 5, and that's it. That pretty much generated, in this case, a new OS file with the examples embedded in them. So now we have a open API specification with valid examples inside them. So this is great, right? What can we do from here, right? So next I'm going to show you the toolkit, or the certification toolkit that I talked about, and the virtual service, how we are able to also generate them just out of this thing, right? So let me hit number 6, which is basically to generate the CTK and virtual service. And what this will essentially do is basically going to build out a Docker image for the virtual service and the CTK, so that any of the members who go and download this, they are able to just refer to the Docker and get it up and running quickly. Okay, so it says that it's successfully completed, but where has it written these things, right? So let's quickly go back here, and what you will see now is in the OS folder, you would see a CTK and a VS directory, right? So there are 2 directories that have been generated. So this is a virtual service. All it really contains is a Docker Compose file. So what is inside the Docker Compose file? So essentially, it's got a Docker image for the virtual service TMF621. That's what we are working on, and a basic gateway with this thing. So that's really what it is. So any member who wants to use this now should be able to just run the Docker Compose and bring this up, right? So let's quickly go here. Let me go back to, okay, so CD OS, and let's bring up the virtual service. So I'm going to do run.sh, and so this is essentially just bringing up the Docker image for us here. All this is a nice virtual service that reflects how an actual service would work, right? So this allows a member to poke at it and understand what is expected from the API. So it says, okay, this is running on localhost 9000. So let's quickly jump there. So I'm going to go here, localhost 9000. And the virtual service basically brings up the Swagger UI. It says, yeah, this virtual service is for trouble ticket, the API specification that we just generated. Let's point this to localhost 621.8621, where this service is running. And let's go to post, and let's try this out, right? So I'm going to say try out. And you'll notice that this example, this is the beauty of providing the inline examples in the specification, right? The examples that we generated. So it's able to pick up this example, and it's got the whole example here. Let's execute this. Let's see what happens. And so this request was actually sent to the virtual service that is running, and the virtual service responded back with this response, right? So it's created a trouble ticket. It's got an ID 3180. Okay. So it's created a trouble ticket with ID 3180. Perfect. So let's now go to the get request, and let's see what happens if we execute this. So that's the request that was sent, and sure enough, we got an array of objects, but in this case, we only have one trouble ticket. So this is basically ID 3180. Remember the ID that was generated? We've got this ID. So here you have like a fully functional mock, if you will, right, or a virtual service of your essentially API from your API specification. And all of this is completely automated, so you can get a virtual service up and running quickly. So if you were a consumer who's consuming this API, you could literally start your development by referring to this running instance and integrate with it, right? If you're a developer of this API, then this is a good first look at, okay, how is the API supposed to behave, and you can then start building your API. So yeah, so that's the reason why we produce the virtual service from this. So perfect. So we've got the virtual service now running. You've seen the virtual service in full glory. Let's now go and look at what is in the CTK, right? So actually, before, let me just show you what the CTK is. So again, the CTK is simply a Docker image, which is this thing, and it's just volume mounting a couple of things. So let me quickly run the CTK, right? So who would use the CTK, right? So anyone who any of the members who say who would basically claim to TMF that we have implemented this specification, they would after they have done the implementation, they would actually run the CTK against their implementation and prove that their implementation is in fact as per the specification. So the CTK is a essentially a contract test that will validate whether your implementation is adhering to the contract or not, right? So let's run the CTK. And as you can see, it is just spinning up and loading. It's firing all the requests, and that's it. It's basically run 10 tests, and all 10 tests were successful. Of course, let's quickly look at the report itself and see what is in the report. So here we ran 10 tests, and they were, basically again shows you against trouble ticket. We did a post, a get. In the post, we got a 201 response, and you can look at exactly what was the request that was sent and what was the response that it got back from the. Of course, this is hitting right now the virtual service. That's how it's working. But in reality, you would point this to your actual implementation and make sure that all these tests are passing, right? So that's basically how the CTK works, right? It's essentially a contract test for your implementation. So I think this is pretty much. Let's go back here and look at what else do we have. So we have a Postman collection that we can produce, which if someone wants to, then use the Postman collection, they can, and conformance profile and a user guide. So we generate all of these artifacts through this, right? So yeah, in a nutshell, right from basically designing the API, generating the open API specification, generating the examples, and then generating a virtual service and a conformance toolkit or a test, a contract test for it. All of this is completely automated, available for any of the members to be able to, create a new API and then test over the API once they've implemented. This really speeds up and powers the developer experience in what we have seen, right? Let me quickly switch back to my slides. So that was a quick demo of the API design and artifact generation process. So this is really the first part, right? And then our CI pipeline would basically take these artifacts and publish them on the website. And so this is how these artifacts will show up on this website that I was showing you, right? So this is how they would start showing up over here. All these artifacts would come through this process. Now, this is part one of this entire thing, right? So let's say you've got now all these artifacts, right? So this at this point, basically TMF has published these, and they are available for any of the members to go ahead and implement these API specifications. So what happens once we move forward from there, right? So I want to quickly introduce a concept called the open digital architecture component, right? So what this is essentially it's kind of taking each of these API specifications and then logically grouping them into business components, right, if you will. And providing, so the business components provide like the core functions, which is provided by these APIs, and then the security standards, if you have some business metrics that you want to monitor and so forth, right? So this is basically each component would have a set of exposed open APIs and a set of dependent APIs on which they depend on, right? Why I'm explaining this is typically as a member, I would look at, this is the business functionality that I want to implement. This is mapped to this ODA component, and then I would say, okay, in this ODA component, what are the APIs that are exposed and what are the APIs that it depends on, right? And then, so what would happen is that you would have a Git repository for the ODA component itself, and it would have a component build pipeline, right, which basically will auto generate the Helm and other kinds of things from a deployment point of view. And each of the APIs that we just talked about, each of the APIs will have their own implementation residing in their respective Git repos. I mean, this is using a monorepo, not using a monorepo, but you could certainly use a monorepo. Each pipeline, each Git repo or each API would have its own build pipeline, which would generate its respective artifacts. We'll look at that in a second, what artifacts each of them generate. And then any changes made would trigger the component build pipeline, which would then generate the respective artifacts, which are then used by the release pipeline. It first deployed into an ephemeral testing environment and then into an actual integration testing environment, and that would be your path to production, right? So whatever APIs that we had produced, the specifications essentially would be leveraged here to essentially for the implementation. And in this pipeline, we'll also see that we run the CTK to make sure that it's adhering to the specification before we actually release it, right? So let's double click and zoom into what this pipeline itself looks like, right? So if you look at this, this obviously will contain the API implementation code. It would have environment-wise configuration. If it's using a database, then you typically use something like Liquibase. If this has capability where you want to toggle off things, then you have a feature toggle. So all of those would reside into this Git repo. We would provide a config which is in a similar format like Helm. So we would provide things like health probes, auto scaling, word affinity, other kinds of important things for this particular API. Then we would use Specmatic, the open source tool that I've been talking about, which has in the specification exposed APIs and dependent APIs, and then of course branch policies and things like that, and then pre-commit hooks, which is all linters and code tests and all of them passing as part of the before you commit, before you raise a pull request. So this is, once you raise a pull request, this is how the pipeline today looks like, right? So we spin up an on-demand agent, we run the CI tests, we run a whole bunch of SecOps tools, right? And then we publish all these contracts and artifacts, and then finally, this is deleted and cleaned up. So if you look at one of these that we recently ran, you would see that as part of this, we lint, and then we run unit tests, we run component tests, and we also run contract tests. If we double click into the contract test piece, you would see that again here, we are using the same tool called Specmatic to run all of these tests. And here we've turned resiliency testing on. So it's generated 2,248 tests and basically made sure all those tests are passing before we move forward, right? So this provides a solid feedback as part of the pipelines itself. Of course, this can be run locally as well. Developers do that, and then when they run it on the pipeline, we want to make sure that all these tests are passing. And only when they are passing, then we move forward and we release some of these artifacts into an ephemeral environment for testing. So in an ephemeral environment, again, there is a specmatic Kubernetes operator that what it would do is it look at the specmatic config file and say, okay, the product inventory is actually dependent on product catalog and service catalog, for example. So it will spin up the HTTP stubs or and gRPC stub in this case, right, automatically for you, so that in the ephemeral environment you can just focus on testing your product inventory service, right? And the rest of them are all are stubbed out, and the stubs are all again powered by the same open API specifications that were generated, and the examples that were provided in that are used as test data over here, right? So this is now without any much effort, right? Whatever API specifications were there, the same API specifications are being used for testing and stubbing out things for you, right? And then, of course, because you have an understanding of which component depends on which, and which API is supposed to talk to which API, we also automatically set up the MTLS, the mutual TLS for the dependent components, right? And again, no coding required. It's all automatically done as part of the pipeline. Same thing you can do with network policies and so forth. So you can, basically by default in Kubernetes, anything can talk to anything. But if you belong to the zero trust kind of school of thought, then what you would do is you would basically shut everything down. Nothing can talk to anything else except what is dependent, which API is dependent on which other API, which is all again documented in the component specification, and that's where all of this is coming from, right? So I think this is pretty much it. Kind of quickly going through and explaining how the overall process on the design side of things at TMF is streamlined, and then the same set of output that is provided, like the CTK, the Open API specifications, are then used in the members' development and build pipelines and testing environment and so forth, right? So this whole effort is what we are calling as API Forge. The tool that we are showing here, Specmatic, which is powering all of this, is obviously available. It's open source. You can check it out on GitHub. And yeah, happy to take any questions you may have.